Since the Locked On update that came in the spring of 2019, War Thunder has been regularly receiving vehicles equipped with radar systems. Various types of radar help control your vehicles, detect targets at longer distances and in poor weather conditions. Today, radar systems can be found on planes, helicopters, ground vehicles, and even naval vessels. But what are those types of radar, and how are they different? The first type is a radar rangefinder. It allows you to lock on targets along a fighter's bore sight line and continuously measure the distance to it. The data feeds into the gun's gyro sight to calculate lead. Radar rangefinders use a wide fixed beam, which improves detection and lock-on time. But this system comes with some flaws as well. They're affected by ground clutter and thus incapable of detecting targets at distances exceeding the fighter's altitude. To control this radar, you only need one button: Lock Radar IRST on target. It's a simple on-off switch. Once you turn it on, it locks onto the first target in the direction of your flight and tracks it. If the target is lost, the rangefinder starts looking for it automatically. The next type of radar is the search radar with a fixed beam. Its working principle is very similar to rangefinders. They too use a wide fixed beam to scan your environment in real time, and they suffer from ground clutter just as much, so they can't detect objects at distances greater than your fighter's altitude. The main difference found on this radar is its ability to track both distance and direction of your target. To use this radar, you'll need to assign a button for Switch Radar IRST Search on/off. Now let's talk about more modern scanning search radar. These can be found on both planes and most anti-aircraft systems. This radar can provide both distance and direction data about targets, employing a narrow beam that can perform azimuth scanning of either a sector or the full 360 degrees. Due to this feature, it can't show real-time data. The display is only updated after the scanning beam finishes its sweep. On the plus side, this type of radar has a larger range than fixed beam radar. They can also be divided into two subtypes. The first one scans the whole sector vertically using a wide beam. These radar systems are susceptible to ground clutter and cannot find the target's elevation. The second subtype scans a few bars moving along a narrow beam vertically. When the beam scans an area above the horizon, the ground creates much less clutter. Moreover, these radar systems can find the target's approximate altitude. To control scanning search radar systems, you can use the following functions: Switch Radar IRST Search on/off, change scope scale, change search mode, select target to lock, and change radar IRST mode. Now, we've mentioned ground clutter a few times already. Up until the mid-1970s, fighters suffered significant interference from it, preventing beyond visual range missile launches. Detecting targets below the horizon level has always been difficult because the beam would touch the ground. War Thunder can indicate the clutter in radar scope and show its strength level. In addition to that, target detection may be harder if the fighter flies at a low altitude. It happens due to the radar's side lobes emitting and receiving reflected signals. If the distance to your target is less than your altitude, ground clutter isn't a problem, since the enemy shows up in your scopes before the clutter does. But all of this is only true for older pulse radar systems. Technology progress taught radar systems to look down. These systems use moving target indication, or MTI for short, and the pulse Doppler principle, or PD. Both technologies allow the radar to separate ground clutter and moving targets by their radial, or Doppler, speed. PD radar systems generally provide better object separation and better detection range in look-down modes compared to MTI radar. Still, early PD radar models like the one found on the British Phantom cannot range targets in search mode, only showing direction and radial speed. Moreover, both types share a flaw. They cannot detect targets below the horizon if the targets are flying perpendicular to the radar beam. Early pulse Doppler and MTI radar systems also experience issues with detecting tail-on targets, because terrain moves at a high speed relative to the fighter, and ground clutter prevents detecting targets flying along the same direction. More advanced radar systems, such as the ones found on the F4EJ KAI and the J37 Viggen, can detect targets well, both tail-on and moving towards them. By the way, ground clutter is just as much an issue for ground radar systems. Pulse Doppler and moving target indicator technologies had been implemented there even earlier than on aircraft. Since ground radar moves less, and almost not at all compared to aircraft radar, they show a more reliable performance. The increasing popularity of radar naturally led to the invention of countermeasures. We call it chaff. Chaff is basically pieces of foil that show up as fake radar targets. Aircraft equipped with early radar systems see fake targets in search mode and have troubles in tracking mode as well. Meanwhile, pulse Doppler and MTI radar systems are resistant to chaff. They can ignore countermeasures in search mode, along with the ground clutter. In tracking mode, chaff only works if the target is flying away from the fighter or moves across its course. No chaff can prevent lock-on if the target is flying at the radar. Still, radar systems are used for more than target detection on fighters. They can also be employed to hit targets with semi-active radar seekers. These seekers work much the same way as regular radar. The only difference is that the emitter is found on board the fighter, while the receiver is on the missile itself. There are two types of radar seekers. The first one is a pulse radar seeker. These can be found, for instance, on the R3R and the R530 missiles. Much like pulse radar found on fighters, they're susceptible to ground clutter and can be fooled by chaff. The more advanced type is continuous wave seekers, like the R23R, the R24R, and the Sparrow. They work like the pulse Doppler radar and use Doppler filtering to separate ground clutter and chaff. Much like PD radar, they cannot track targets flying below the horizon level across the line of sight, and their tail-on range is much shorter. Another type of radar found on aircraft and ground vehicles is tracking radar. It's used for automatic target tracking, gun aim, and air-to-air missile launches. They can use both fixed and tracking beams, measure distance, and find the target's direction. For instance, the MiG-19 PT radar uses a fixed beam and its maximum tracking angle is only 7 degrees around the bore sight line. Meanwhile, the F3D1 uses a tracking beam, so its maximum tracking angle reaches up to 60 degrees around the bore sight line. Moreover, such radar systems have a significant range advantage. The radar on the Tunguska and the Gepard use a tracking beam too and can also rotate 360 degrees in azimuth, or move between -10 and +90 degrees in elevation. The tracking radar on the D3D1 and the MiG-19 PT can lock onto targets in a narrow sector at a specific distance along the course of flight. The Tunguska and the Gepard radar systems can acquire a target by designation from the search radar, in third-person view, or by optical sight. You can cycle targets to lock on by pressing Select Radar/IRST to lock, or with a moving target queue that can be controlled by keys assigned for Horizontal Radar/IRST target queue control axis and Vertical Radar/IRST target queue control axis. These axes only work if you disable the option called Targets Cyclic Switching of Aircraft Radar for planes and helicopters, or Targets Cyclic Switching of Ground Radar for anti-air vehicles and vessels. A tracking radar performs a fine search in the specified area to lock onto a target, ranging direction and distance. If there's more targets in the area, it can lead to a lock on the wrong plane or helicopter. Moreover, a target with a high angular velocity at close range can move out of the tracking radar's detection area, rendering the fine search useless. It might look like a bug, but it's a real-life problem for radar systems replicated in the game. To control the radar, you can use the Lock Radar IRST on Target button. On aircraft, this command turns the radar on and off, which then automatically locks onto a target, tracks it, and tries to reacquire it if it's lost. On anti-aircraft vehicles, this command is used to acquire a target by search radar designation or by optical sight. You should keep in mind an unpleasant phenomenon happening when tracking low-flying targets less than 100 meters above the ground. Due to signal reflection, the so-called multipath effect, the direction to the target may shift lower. This effect appears even when the radar system has a pulse Doppler or an MT1 mode. In such cases, an AA missile operator might want to switch to the optical tracking system if they have one, or target the missile manually. As for fighters with semi-active radar homing missiles, the only thing that'll help them is a high angle of attack. And now it's time to talk about the system that adds this IRST part to every command we've mentioned. IRST stands for Infrared Search and Tracking. It's a passive sensor that can detect a target's infrared signature. Some radars, such as the one found on the MiG-23, can only give the direction to the target. Others, like on the Stormer, are equipped with a laser rangefinder that can add distance data. To switch to the infrared search and track sensors, use the following command: switch between radar and IRST. We'd like to finish this video with the most complex systems: combined search and track radar capable of tracking targets in multiple ways. For example, the MiG-21 SMT in air combat maneuvering mode can acquire targets in a narrow sector along the bore sight direction. The Mirage 3E in beyond visual range mode can attack the selected target even out of sight. The Phantom's radar systems can acquire targets in both modes. Let's go over the controls one more time with search and track radar systems. Switch radar, IRST search on-off, switch between radar and IRST, change scope scale, change search mode, select target to lock, change mode, beyond or within visual range combat, and lock on target. That's it for today, friends. Our long story about everything that has radar in it has come to its end. We wish you less clutter and more beyond visual range frags.